Hello everyone. In this video we are going to discuss some of the very important terms which are used in magnetism. So go through the video very properly and at the end of the video see to that if everything is clear, and if there is any doubt which is left out, then you can post me the doubts. So the first term that we are going to discuss is magnetizing force. Magnetizing force. The magnetizing force is represented by H. Capital H represents magnetizing force. And to understand the concept of magnetizing force, let us take two different types of magnetic field. These are shown by the parallel lines. Uniform magnetic field. We are considering two regions here. Now one of the region, you can see that the magnetic lines are stronger here because they are closer to each other. Magnetic field is stronger here. Now if you keep a magnetic material here and the same magnetic material if you keep here, the magnetic material gets magnetized in a magnetic field, we all know. But the magnetization will be more in the first case where the magnetic field strength is more. So this gets magnetized more as compared to this magnetic material. This gets magnetized more as compared to the second one. So the magnetization actually depends on the amount of magnetic field which is provided. Now magnetizing force is the property of a magnetic field which decides the extent to which the material will get magnetized when placed in the magnetic field. Okay, always remember, you have to always remember that magnetizing force is the property of the applied magnetic field which decides the extent to which a magnetic material will get magnetized. Okay, now obviously therefore we will write the magnetizing force to be directly proportional to the applied magnetic field. Let B naught be the applied magnetic field, so we can write this. So the magnetizing force is equal to some constant, and the constant is 1 by mu naught. Mu naught is the absolute permeability of the medium. So therefore we have the equation for H, which is given by V naught upon mu naught. So this represents the value of magnetizing force. So you can see here, you can just quote it down. This is the value of magnetizing force. Now if you want to find the unit of magnetizing force, so for the unit of magnetizing force, B, the magnetic field has a unit of Tesla, and for mu naught it is Tesla meter per ampere. So if we write it, so we can write here ampere per meter. So ampere per meter is the SI unit of magnetizing force. So I hope this is very clear to you. Here one equation for the applied magnetic field B naught in terms of the magnetizing force can be written as mu naught into H. So this is also a relation which you should remember. So I hope this magnetizing force is clear to you. Now the second point that we are going to discuss here is, let me rub it off first. The second point that we are going to discuss here is intensity of magnetization. Okay, intensity of magnetization, the second point. Second point. Intensity of magnetization. Now intensity of magnetization is represented by I, and to understand this, suppose we take two regions where the magnetic field is same. The magnetic field is same in both the two regions which are shown here. Now magnetic material, we are keeping it different. Suppose in one of them the magnetic material which we kept is say iron, and let's say another we keep of copper. Now we will see a change in the magnetic lines of force. We will find that the magnetic lines of force are curved here, and they are actually attracted by this magnetic material. Okay, whereas in copper you find that it is not the same. So if we calculate the magnetic induction here, the value will be more here. You can see here in this region the magnetic field has actually increased from its initial value. So the material also have its own property which decides the amount in which it will get magnetized when placed in the same magnetic field. Two different materials having different intensity of magnetization, which is the property of the material itself, which decides to what extent it will get magnetized when placed in a magnetic field. So you need to understand these two terms very carefully. Magnetizing force is the property of the magnetic field, whereas intensity of magnetization is the property of the magnetic material, which decides the extent to which it will get magnetized. Because iron and copper placed in the same magnetic field, iron will get more magnetized because its intensity of magnetization is more. Mathematically, suppose we consider a magnet here, let this be the bar magnet, and if we have south pole and the north pole here inside the magnet, suppose we want to find the intensity of the magnetization. That means we bring a magnetic material here, and suppose we consider this to be the magnetic material only. Instead of considering it to be a magnet, let this be the magnetic material. We have brought this magnetic material. Now when it is brought in a magnetic field, then it becomes a magnet. It behaves as a magnet. It will have a south pole and a north pole, and the length of the magnet will be given by twice L. This is the length of the magnet, and pole strength it develops is N. Then intensity of magnetization is given by the magnetic dipole moment M divided by the volume. Cross-sectional area be given by A. So I therefore can be written as, we can write here as M is pole strength into the length, which is twice L, divided by volume will be A into twice L. So this will cancel out and we will have intensity of magnetization, which will be given by M by A, pole strength divided by the cross-sectional area, which initially was written in the form of dipole moment divided by the volume. Now the unit we can find out. Pole strength has a unit of ampere meter, and area has a unit of SI unit of meter square. So 1 meter will cancel out and we will have as ampere per meter the unit of SI unit of intensity of magnetization. And you can see that the magnetizing force as well as the intensity of magnetization both have the same SI unit. So don't get confused about them. Okay, we move to the next part now. Let me rub this off first. See, when we consider a magnetic material, when it is placed in a magnetic field, then it attracts the magnetic lines of force, which is shown here. Now the third point we are going to discuss is magnetic induction. magnetic induction. Now suppose the initial applied magnetic field is given by B naught, and now after placing a magnetic material, naturally the magnetic lines of force have come closer to each other. Now at this point the magnetic field, let it be given by B, and this phenomena of change of the magnetic field to B is known as magnetic induction. And naturally this value of B, which is the final magnetic field here, will depend on the initial value plus it has increased now, so it will depend also on the intensity of magnetization of the material. More is the intensity of magnetization, more lines will be attracted, so it will depend on I, the intensity of magnetization. So a constant term will come here, and which is mu naught. So the value of magnetic induction at a particular place will be given, when we keep the magnetic material there, will be given by B is equal to B naught plus mu naught into I. Now we have already seen that the value of B naught can be written as mu naught H in terms of magnetizing force. So here B can be written as mu naught H plus mu naught I. So we can write B, mu naught can be taken as common, so we write H plus I. So this represents the value of magnetic field which is produced after bringing the magnetic material, so that is known as magnetic induction. So I hope this is also very clear to you. Now let us move to the next term, that is magnetic susceptibility. Magnetic susceptibility is the ratio of the intensity of magnetization to that of the magnetizing force. So we write here magnetic susceptibility. Magnetic susceptibility is given by, symbolically it is represented by chi m, and it is the ratio of intensity of magnetization to that of the magnetizing force, and obviously it is dimensionless. Because I and H, they have the same unit, ampere per meter. Okay, and the last term which we are going to discuss here is permeability, relative permeability. This relative permeability mu r is actually given by 1 plus chi m. So let us see how we can actually derive this relation. We have already seen that B is given by mu naught into H plus I. This formula we have already seen. So we divide each of the term by H. So the first term here, mu naught H by H is 1 and I by H is chi m. So we have this relation, and B by H, we know H is given by B naught by mu naught. So B naught by H is mu naught. So B by H will be mu. So we write mu here is equal to mu naught into 1 plus chi m, and mu naught comes here, so it is mu r, that is relative permeability, which is equal to 1 plus chi m. So this you need to understand. And these are the terms which are used in magnetization, magnetic field intensities and everything, whatever we have discussed here. Go through the topic very carefully and see to that if there is any doubt, then post me the doubts. Thank you.